So today we want to solve the differential equation by linear substitution, and our example 1 is y squared minus xy minus 8x squared over x squared is equals to dy over dx. So we have three different methods of solving differential equation, but today this one I'll call it our method 1 because you'll see how it will go by. So number 1, when you see wherever you see such equation so that the constant at the numerator and denominator is 0, we directly go and let y to be vx. After letting y to be vx, then I now find the dv over the dx. So for me to find the dv over dx, I just differentiate. So the derivative of dv with respect to dx will be v plus x dv over dx. Good. So at this particular point, I'll just replace y squared. What did I say y to be? Y is vx. So I'll have vx, but this time is squared, minus x times y, and my y is vx, minus 8x squared over x squared is equals to dy over dx. But what did I say my dy dx to be equal? Dy dx to be equal to dv of dx, which is also equals to v plus x dv over dx. So what will I do? The first thing, I want to solve this particular part here first of all. So by solving that one, I have v squared x squared minus x squared v minus 8x squared divided by x squared. So x squared is dividing everything, and you will see that in the I can still write this equation to be v squared x squared over x squared minus x squared v over x squared minus 8x squared over x squared. So you'll realize that whatever I've done in the denominator is just the same thing that I have here. So this one will give us, because x squared will cancel out, so we'll have v squared minus x squared cancel minus v, then again minus 8 because x squared cancels, should be the same as v plus x dv over dx. Why? Because we say that our dy over dx to represent v plus x dv over dx. Why are we representing? Because we are removing our dy and we are expressing it in terms of dv over dx. Good. So at this particular point, we subtract v both sides. I subtract v there, I subtract v this side, so that I have v squared. I can say now, sorry, I'm subtracting v squared. I'm subtracting v squared this side and this side. So I'll say v squared minus v is minus 2v minus 8 is equals to x dv over dx at this particular point. And you realize that I have x and dx here, but the v's I have the other side. So I'll bring dv this side. For me to bring dv that side, I multiply by 1 over dv, such that dv cancels dv. I multiply the same side by 1 over dv, so that I'll have my now x over dx to be equals to v squared minus 2v minus 8 over dv, because I was multiplying by 1 over dv, meaning I'll divide with the other side. So good. So at this particular point, what do we do? What do we do when we reach at this particular point? So at this one, we reciprocate. I'll write here to reciprocate, meaning finding the reciprocal means I'm getting dx over x to be equals to dv over v squared minus 2v minus 8. Whenever I reach here, I integrate, and ODE or D is just integral. It's just more, it talks much about integral calculus, so that when we're doing an ODE or a DE, most specifically we reach at integration. So integration, I can just say that this is just the same as, I can say this is the same as dv over x minus the integral of dv over v squared minus 2v minus 8. This one equals to 0 whenever I equate it to 0. So by integrating this one, this is the same as, sorry, it's not v but it is x, is the same as 1 over x with respect to dx minus, I'm integrating, integral of 1 over v squared minus 2v minus 8 with respect to dv. So 1 over x, everybody knows that for us to integrate this is just the same as ln of x, minus the integral of this one. So for us to integrate this one, because we can't factorize the denominator, we use integration by partial fraction. So by partial fraction is just the same as factorizing the denominator, and for me to factorize v squared minus 2v minus 8 is just the same as saying 1 over is just the same as saying 1 over v squared minus 4v, because I'm looking two numbers. When I multiply I get 8, when I add I get negative 2. That is the same as v 4v again plus 2v minus 8. Good. So at this particular point I know that is the same as 1 over v minus 4 v plus 2, and I'm finding the integration of this. I know that here I've already integrated, I have a ln x. Good. So that is the same as integrating is just the same as 1 over v minus 4 v plus 2, which will give me, I'll introduce constant a over maybe v minus 4 plus b over v plus 2, b over v plus 2. So I integrate the this part. This is whatever I'm doing here is just using integration by partial fraction. So we are interested in finding the values for a and b. So here we look at the LCM, and our LCM is just v minus 4v plus 2, such that whenever I simplify this, I'll just say 1 is equals to, this one cancels this, and we have a into v plus 2 plus, this one cancels, and I have b into v minus 4. So this is the same as 1 equals to, so I want to find the value of a. So for me to find the value of a, I make b as 0. For me to make b as 0, because here I have 4 minus 4, I add 4. So 4 minus 4 is 0. So 0 times b is b. So I add 4 the other side, so that I have 6a. So 1 is equals to 6a. So the value of a is 1 over 6. Similarly, when I want now to find the value of b, I make a to be 0. So for me to make the value of a to be 0, I use negative 2, so that when I take negative 2 plus 2, I get 0. And 0 times a is 0. So I have 1 is equals to b into negative 6, because v is negative 2. So I'll have my b being negative 1 over 6. Then I just replace the values I've gotten here and then integrate. This is just the same as saying 1 over 6 all over v minus 4, the integral of it, plus b, which is negative 1 over 6 all over v plus 2. But remember, we are integrating with respect to dv. So because 1 over 6 is a constant, I'll bring it outside here, so that I have 1 over v minus 4 dv plus, so it will be a minus because I'm bringing that one outside there. So it minus 1 over 6 minus integral of 1 over v plus 2 dv. Good. So this is the same as say 1 over 6 ln v minus 4, the absolute value, minus 1 over 6 ln v plus 2. Good. I think by doing that one we've integrated. But remember, our y was vx. So I want to find the value of v, because v we were not given in the question, so that I use y and x. So we know very well that now our v will just be the same as y over x. So this is just the same as saying we had ln x minus 1 over 6. So ln x, we get it at this particular point. So it is ln x minus whatever we integrated at this part, and we have integrated and come up with our final answer. So it is ln x minus 1 over 6 ln v minus 4, but my v is now y over x. Minus 1 over 6 ln v is y over x plus 2, and this is equals to 0. And our 0, whenever we integrate a 0, we find a constant of integration. Thank you for watching the video. Please ensure you subscribe and add a comment if any in the comment section.